So for the third problem, the transportation, we are given uh, a situation in which a book company is uh, is trying to handle different configurations of which warehouses to operate. And in this current situation, we it is positioned in such a way that only one of the warehouses, which is Western, is responsible for supplying as supplying the initial inventory of books and then supplying it towards the other warehouses. So as you can see from the given, it involves some concepts from operations management. So particularly safety stocks as well as service levels. So the computation is going to be quite complicated, but let's see. Let's go. So from this initial table, matrix, this represents the supply and demand table. So because the central warehouse will be located in Western, that will be the main focus of our current situation here. So because the weekly demand of books is 50,000. So 50,000 will be the demand for each of the locations. So it might seem confusing because the Western warehouse, it ships from itself, but it just represents the type of demand that is expected for each of the locations. So each location has 50,000 demand units of demand. And then as for the shipment cost, because is the Western warehouse is the only one involved, the rest of the warehouses values, the demand as well as the shipment costs, they are zero. So they are not involved in the shipment of the supply of the inventory. So moving on, shipment cost. The shipment cost is this is taken from the weekly demand, which is 50,000, and then it is represented in proportion to the other warehouses. So this, for instance, the Western this warehouses, they are in a line, So the Western warehouse is the closest one, which is the source itself, and then it moves one unit to central warehouse, and then also one unit to Eastern. So uh, because of that, the proportion is going to be represented in the given here. So as you can see in the shipment cost from Western, uh, because it is 2 units to reach Eastern, it is going to be a 4/4 proportion. So it is the farthest one, and from the cost, the cost is fully representative of the weekly demand of books. And then as we get closer to Western, which is central, it has a proportionally smaller weight. So from 50,000, it 4/4, it results to 3/4, and uh, the cost is 37,500. And then same deal with the Western. So because it is the nearest, it's half of the proportion of Eastern. So that explains the cost from 50,000 to 25,000. As for the weekly warehouse fixed cost, so to simplify the formula, it is explained as the summation of the annual fixed cost as well as the annual holding cost, which is divided by the time period of weeks in a year, which is 52. So, ayan, the annual fixed cost, this is assumed to be given, 200,000. Well, which is simple as, it's just included there. But the annual holding cost, this is a lot more complicated. So, annual holding costs, to break down the formula right here. uh, so, we will, this this value right here, this seems like a constant, no? The this is represents the holding rate, the ones the holding cost, no? This is represents the what each inventory will be, each inventory's holding costs will be. So $1.5 per unit. So as for the inside, no, we can see that it's similar to safety stock. So safety stock, it involves the service level, the z-score of the service level, which is 99.7%, and then square root of T and L. So T and L, that represents the review period as well as the lead time. And since the problem asks, no, for weekly period, they can be assumed to be 1. So 1 plus 1 is square root of 2. So the square root of 3. So what is it doing here? No? This is added to the formula of annual holding cost, because it represents, no, it represents the distribution of the current situation. So ayun, from the table we can see that there are three independent demands, but only one warehouse. So that effect, it magnifies, no, it we have to account for the variations that will happen in the transfer between from the central, from the western warehouse to the other warehouses. So square root of 3, that represents the three types of warehouses that exist, and they are affected by similar enough, no, standard deviations. So that represents the variation. And then as for this sum, as for additional sum, no, this represents the cycle stock. So what is cycle stock? It is essentially explained as the regular working inventory. So the average demand that can be expected from each cycle in each of the warehouses. So as they are transferred to the destination. So all in all, no, when added together, no, uh, this will be the result, no, around $13,000 of fixed costs. And moving on to the cycle inventory cost. So it is also as you may notice, no, the first part, or the total order quantity, it is similar to the cycle stock. So this is just a reframing of context. So because the one cycle, it represents the average amount that the units are expected to be fulfilled. it it is also applicable to the total order quantity, no? So that represents the overall demand that is expected. So ayun, to fully get the what the relevant information. So it is divided by 2, and then it is then multiplied by the unit cost, which is the given here, the average cost of both, as well as the holding rate. So holding rate, it is also assumed to be a given, but it's not here. And then all of those, they are divided by the weekly period. So 52. So just so you can see that it results to 3,000, around $3,000. And then as for the safety inventory cost, the weekly, so we just take the normal formula for safety stock, and then consider the effects of unit costs as well as the holding rate, and then divide by the weekly period. So, and all in all, no. So as you may notice, the only warehouse that incurs these types of costs is the one that is selected, the one that is the main supplier. So ayun, but the shipment costs, it will still be considered in the total weekly cost of the other warehouses. So ayun, all in all, just sum summarize all the costs so far, and then and then when it is summarized for the three warehouses, that's where we arrive at the total cost. So in this another example, no, this is also similar approach to the previous one. So we just happen to change the location of the main hub in which the warehouse, no, the warehouse will be chosen from, no, the one that will supply to all other warehouses. So in the example earlier, we have chosen Western warehouse, but now this has chosen the central one. So there are minimal changes to this. The cost, the formulas for the weekly warehouse fixed cost, cycle inventory cost, and safety inventory cost, they are the same. No? As you can may notice, no, they are the same value. But what is slightly different from this is the computation of the proportions. So portions in the shipment cost. So because central is in between the two warehouses, so they have a smaller proportions than compared to the western one. So ayan, uh, it's just they're just the eastern and western warehouses are just one unit away from central. So that slightly changes the shipment cost. But same procedure still. So just compute the total cost and then from each of the warehouses, and we arrived at around $126,000. So as you can see, no, even if the procedure is similar, but by changing the location of the main warehouse, we are able to drive down the total cost. And for the last example, no, uh, this will involve, no, using each of the warehouses as their own hubs. So they operate independently of one another. So uh, each warehouse supplies its own demand. So there's no sharing. There's no shipment from western then to central or then western or then to eastern. That it doesn't exist. No? So each one has its own fulfillment. So warehouse, all of them have yes, and then this is reflected in the the table right here. So the eastern and eastern each have their own, and then eastern to everything else has none. Okay, the computation will still remain the same, and the proportion is just the base proportion, which is 1/2, and then this exists for all other locations. And then, oh yeah, the warehouse operating cost. So I forgot to mention that uh, this is just simply the summation of all of these shipment costs from all of the warehouse, which is also the cycle stock or the total order quantity. So just sum it up and then multiply by a constant, which is 0.01 or 1%. So that's how you get the warehouse operating cost. And then no, and then as for the formula, um, it is it is still the same, no, still the same. The only difference is that the part where we have to include the square root of uh, the three warehouses, it is now gone. No, it's not considered anymore because every location, every warehouse, it operates as its own. No? It doesn't depend on others. It has its own variability to take account of. So that's it. So that's it. No, that also extends to the other warehouses, other costs, and just proceed as normal. And that also applies to the safety inventory costs. So ayun, all in all, no, they just sum it up, for each warehouse total cost, and as you can see, no, it's equal. The each location has as approximately the same cost. So just multiply that by three, and then we get the total cost rate right here of around $124,000. So ayun, we have explored, no, how different configurations of warehouse and the demand and the supply can affect the total costs of this business right here. So so far, no, from the three options provided, the lowest total cost is the third option. So it is ideal for the business to establish a warehouse, a dedicated warehouse for each of their locations. So that is it for the transportation, and I hope uh, a lot is learned from this, and thank you for watching.